Yes.
Hi. Hi, everyone. Thanks for joining in. And I'm just going to go through a very, very brief set of slides, just maybe 3 or 4, just to get us going, just to introduce what we mean by data life cycle. And then we can open it up for questions that you guys have. I have a set of questions possible set of questions. And then there are some questions submitted by the workshop participants when they registered. So, so I'm Anirban Mandal. I'm from Renaissance Computing Institute at UNC Chapel Hill. I'm the Assistant Director for Network Research and Infrastructure there, and I'm also a co-PI on the CI/COE pilot project. So what we mean by data lifecycle to start with, so when we developed this data lifecycle model, we were mainly concentrating on large facilities, the NSF large facilities in general, but this can be extended to many other small and large scientific facilities. So by data lifecycle, what we mean is basically a model that captures the end-to-end data movement from where the data is captured by scientific instruments and sensors to the ultimate dissemination and access of the data by the scientists to do further research, right? So every data life cycle starts with what we call as a data capture step, right? So there's some kind of sensor instrument that is used to capture the initial data for different kinds of facilities. Right? It could be a telescope, it could be sensors in the field, it could be the DOMs as in ice cube, it could be the grapes sensor boards as in neon, it could be telescopes and optical, infrared. So you have the whole gamut of scientific instruments which are generating large volumes of data. And then that's a data capture step. Everything starts from there, right? And then you might have some kind of initial processing of the data that happens really close to where the data is generated or where the data is measured. That step we call as initial processing step. It's often at a sensor site or very near where the data collection really happens, right? You could do some initial filtering of the data, you could generate some alerts, you could do a variety of processing, but not very, very heavyweight because you might not have the entire compute capacity very close to where the data is captured, right? Then in most general cases, data is moved by various means through network circuits, through normal internet, through satellite, boats, a whole lot of mechanisms to what we call as a central processing step where you do the bulk of processing in one or more data centers or compute processing uh, uh, places, right? It could be distributed set of resources. It could be from campus clusters. It could be the NSF supercomputers. It could be Exceed. It could be OSG. Depends on what facility accesses what kind of compute resources, right? So central processing could happen in one or more data centers, and you then kind of archive the data, you store the data and curate the data, right? And it is debatable as to what happens before and after. So these arrows in the data lifecycle model are very simple to start with, but you could have a lot of nuances in terms of what happens in terms of there being loops or there being other kinds of dependencies between these stages, right? So data archiving and storage is also a very important portion of the data life cycle. And since the scientific facilities gather very important and very relevant data for decades, the archiving, storage, backup of the data is very important, right? And that could also happen in multiple places. You could use cloud resources to do backups. So there are multiple technologies could be used for this stage of the data life cycle. And after that, pretty much the data is distributed in different means through portals, through programmatic means, through uh, through grid FTP. You could basically share the data to the ultimate stakeholders, the scientists and the scientific community that's using the data that's collected by these facilities, right? Uh, so so what I call are these steps are the most basic, very high level steps of the data life cycle. And then there are certain steps which are cross-cutting across these stages, right? So for example, data movement, it's kind of central to the data lifecycle stages, and they cross-cut across these different stages. Other cross-cutting CI elements could be identity management, could be disaster recovery, so which affect multiple stages of a data lifecycle. So those are what we call as cross-cutting elements of the data lifecycle. So what are the goals for data lifecycle, right? So we wanted to understand and document the CI best practices and solutions for large facilities. And when we started studying these large facilities, it was we thought that can a generalized data lifecycle abstraction help us understand this diverse CI landscape across the facilities? Can it be one way to learn and catalog the CI functionalities for each stage of the life cycle? And then what are the services that are offered by each stage, right? What are the CI architecture elements that support each of these stages, right? Um, and then study this end-to-end life cycle for data as it traverses through the different CI entities, and then catalog the underlying services and the tools and platforms for these stages. So it's a model that it's a very simple model that tries to capture some of the common elements across scientific facilities, and then we can think about the different challenges and different technologies that can help solve those challenges for each of these stages, and also the cross-cutting stages, right? So, at this point, I'll pause and let the participants go at me, like ask questions in terms of do you have are you representing a large facility? Are you representing a research organization, research computing? So different people will have different views of their life cycle, and I would just open it up for discussion at this point. I have some questions here, which I might use to corral the discussion. But please go ahead and unmute yourself and ask questions if you got some. So I guess to get it started, uh, I'll just go with the first question. Do you think, like for whatever facility you're representing, whatever organization you're representing, do you think this data life cycle sorry. Do you think that this data life cycle figure captures all the steps that data goes through in your organization? Do you think any critical stages are missing? I know it's early in the morning. Somebody can get it going.
Could you maybe put up the figure again?
Sure. Yeah. So what we're seeing as we talk to a lot of these large facilities, that one of the important concerns is basically how do you do say disaster recovery, right? How do you do migration of certain data and services from uh, uh, from the normal platforms to maybe a cloud platform, right? So uh, there are different issues that are raised when you are trying to when you're trying to say migrate from an older technology to a newer technology, right? So you really need to understand what are the what the CI that's available, what CI you have, and what are the expertise that you need to build up to get to where you want to migrate to, right? So there are different issues that come up for another cross-cutting element that comes up a lot in our discussions is how do you actually support fair data principles in this framework, right? So and having fair attributes is very important. Is an important concern for large facilities to satisfy, right? So yeah, so uh, it's a very general model, but there are lots of nuances that are either cross-cutting, or even the CI for each of these steps can be incredibly complicated, right? Like for central processing, you could think about, say, for example, Ice Cube, right? Ice Cube's central processing uh, starts happening at UW, where most of the data lands up from the South Pole. But then they use a variety of distributed resources from OSG campus clusters. They even use have experimented with different cloud platforms um, to see to perform central processing, right? And even then, if you think about data movement, right, they do a lot of data movement from EW to wherever they're backing up to, maybe NERSC. They might move data to Europe to the DAISY facility. So it's every step can be incredibly complicated, and depends on also on the particular facility. Like for example, in Ice Cube, the alert dissemination goes through a very different path than the normal data product generation, right? So I'd like to get your viewpoints on the different nuances that you might be having in your facilities, and how we could refine the data lifecycle model to get to there.
I don't specifically work at a large facility, but I spent a lot of time doing data work in libraries, and a couple of things that are probably in here that are implicit but not explicitly stated are like the planning steps for how you figure out what you're going to do in the future, even before you start collecting the data, and also change management for when things change, but also as you're recording data, recording metadata. So.
Right. So, so the first point that you touched upon is very important, like doing a requirement analysis for any of these steps, right? So that's so we have asked a lot of the facilities as to the systematic requirement analysis. Many of them have documents, many of them have a process, but it's not done as systematically as it could be done, right? In terms of change management, I think it's very important, because every facility goes through transitions, right? Every 3 to 5 years, things would change, right? Either the funding cycle, or new technology comes in, or so there is you need to keep continuing serving the data to the scientific community, but you need to need to manage how do you migrate from what you have to where you want to be, right? So I think those are very important, interesting concerns that you brought up. The other angle that you talked about is is where all the curation and library science technologies come in, and we're actually thinking about expanding the notion for the archiving and storage step in this model to also include data curation, uh, which is very, very important for really long-term data management, right? And many of these large facilities like serve data for decades, right? So data curation is a very important step, and many of the technologies that we learn from library sciences, information sciences are very useful. We have a project member in our team who's from IU, Angela Murillo, who's an expert in data curation, and we're incorporating that into this model.
Mm-hmm. So one of the things that I ran into with researchers when I was in the library was that I would get their data at the end of their project and have to help them curate it from scratch. But if you're working in a large facility, you have the opportunity to kind of integrate curation throughout the entire process, and it makes the endpoint a lot easier.
Yeah, absolutely. And you know, there's also a relation between curation and supporting FAIR principles, right? So that's another impetus that a lot of the scientific facilities have now, that there's a push for both supporting the FAIR principles. And yeah, the other aspect, I think, which I didn't talk about very much, is the whole issue of identity management, right? So how do you know who is accessing a large facility, who has what rights to do what, and you want to make it easier for people to access, for scientists to access the data repositories, right? So it's also both from a facility perspective, and it's also from the user's perspective, right? From a facility perspective, you sometimes really want to know a trail of who is using your facility, who is accessing your data. It's also used for reporting to say NSF, who is supporting these facilities, right? So so those concerns are also important, right? Yeah. So Doug, I see you are in here. Do you want to give a perspective from Gage about the data life cycle, or any of this any of the steps in the DLC?
Yeah, I was thinking about it because we're kind of in the process, and we're kind of in the process of blowing our data lifecycle up, if you want to think of it that way, because we're redefining it, the way we're going to process data. And one of the things we have to worry about, of course, is keeping compatibility with the old as well, because there are still people that rely on the old way of processing things, and we'll have to support and hopefully slowly migrate them off that. But yeah, the only other thing I was thinking about is, and I don't know if it's true in all facilities, but our archiving to backup really occurs at the initial processing stage.
Right.
Yeah, it's not anywhere. We do, I mean, the other data we keep around forever. So it's really not as much archiving as the initial data stays around for a while and then gets archived in case we ever have to, if there's questions about the data and that kind of thing.
Right. Yeah, that's why I said, like, the initial processing, central processing, and archiving and storage step, you could have it in many different orders, right? I mean, right. As you said, that you could capture and put into storage, and you could do the filtering there, you could do the processing on there, you could do everything, and then you could put it in storage, say, for example, in Neon. So it really depends on the facility and ultimately on the science you're trying to do, right? For example, in IceCube, you'd want to get the filtered data because you really can't get access to the whole data set on the South Pole, because you just don't have the bandwidth to get it to get the entire data set to UW, right? It's just not possible in that case, right? And sometimes you have, depending on the science, you have the users getting access to only maybe the higher level data products, right? So it really depends on the type of the type of science and the facility of doing that, right? Yeah.
It's also true that technology might advance so that you can filter and process things initially in a better way. I talked to a research group that does hyperspectral radar that was bringing that up recently.
Hyperspectral, which group is that?
It's the Townsend group at UW-Madison.
Okay, okay. Yeah, so I mean, nowadays there are a lot of technologies that that we might classify as edge technologies, right? So there's a lot of work that's being done close to the edge of the data collection. So you could do very very high fidelity stream calculations very close to the data capture, right? And you might even start dissemination there. So it really depends on the type of science that every facility will have a different version of the zero life cycle, right? So, but this is kind of think of this not encompassing all the scientific facilities, but as a template that facilities can start with, and then you can expand, you can add more arrows, you could add loops in there. So it's a way to catalog the best practices and to start reasoning about CI, right? So another interesting use case for a data lifecycle is what we call as disaster recovery planning, right? So for every step in this data lifecycle, you might have to bake in disaster recovery, right? And then to plan for disaster recovery, it really helps you to break your CI down into multiple stages, and then really reason about, okay, is this step really important? Can this step be done later on? Some steps might be very, very critical, and you might need to recover at the earliest, right? So that you don't lose any data. For example, capture might be one of the steps, right? If something goes wrong in the data capture step, you would like to really have a disaster recovery mechanism kick in as soon as possible so that you don't lose the data. But central processing, maybe it can wait. If something goes down, maybe it will be a little bit delayed to generate a higher level data product, but you could actually wait a little longer. So when you plan for disaster recovery, you could think of these stages as your guiding principles for determining the priorities for what services to recover sooner rather than later, right? So this again is a framework to make those decisions. So let me. Do any of the participants I know the answer for Gates, but are there any other participants who are thinking about using cloud resources for doing parts of the operations of their scientific facilities? And if so, what are your experiences for doing that? Maybe none of the participants are thinking in those lines, but that's fine. I see there's someone from Hui. Do you represent OI by any chance?
Yeah, no, I do not. I work with R2R, Rolling Deck Repository. Yeah, okay. My work is primarily with them. I do some work with OI, but that's not their primary. Yeah.
Sure. I mean, even R2R, right? It does capture. I mean, the data lifecycle captures not the like for R2R. It's you basically start from after the data capture from the ships, right? So you have the ships collecting the data, and then that data is delivered to R2R, and then after that, most of the steps are handled by R2R, correct? Like you do some processing in Colombia, if I remember correctly, right? And
Yeah,
then
that's correct. We have a couple separate departments. So Columbia, Hui, Samos, they all do a little bit of quality assessment and very little processing, and then we kind of have it available for others
right.
to use.
Right,
Mm-hmm.
right. But and I've gone to the R2R website, and I've seen, like, for every cruise, you basically have different kinds of data, right? Both from like, so I don't know whether the science party data is available from the R2R portal, or is it mostly the data that's the common data that's collected by the ships, which is available to everyone.
So we own our platforms for underway data. So all the instruments are attached to the ship, really. So if a science party brings their own equipment, we don't really deal with that data.
Right, I see. So so thinking about like ARF, right? If you look at the life cycle, some of the interesting concerns for ARF would be in the data transmission, data movement area, right? Because the ships are operating in a very remote area, and they're mostly using like satellite communications, right? From there, many of the technologies used by others might not work there, because they assume you have very reliable connections to the internet, right? So, for example, identity management would be very different for a facility like ARF than for a facility like Gauge or other facility which are more might have more reliable internet connection, right? So the different aspects of the data lifecycle or the cross-cutting stages become important for different facilities, and you would need to look into those stages much more closely. Any other questions? So let me ask a more general question about the scientific community inside your organizations or the universities. So in terms of the resource providers, right, what kind of resource providers are they primarily looking at? I know it's a gamut out there. Like they might be using Exceed resources, maybe the DOE National Lab resources, OSG, and others. So do you increasingly see more heterogeneity, I'd imagine, or do you see a consolidation there? And what are the universities, maybe research computing departments of the universities thinking in those lines, right? And I'm sure there's a cloud story there, and I did attend a few of the sessions in Park and some of the CARC sessions. So I know that there are a lot of people who are looking into that problem. So in terms of this is processing beyond the data collection, beyond the large facility boundary, where it really goes to the entire scientific community. And then in this continuum, there are lots of issues that we are not actually capturing in this life cycle model. So I would like to get any input, any comments and suggestions on that end of things.
Since it's quiet, I'll talk. Tom from University of Utah, represent CARC, Campus Research Computing Consortium, and also a direct research computing facility for the university. And I'm involved with Exceed and Blue Waters and all these projects. And if you look across the NSF portfolio for Exceed, others, there is no data storage. There is no data lifecycle. At my university, researcher wants to have the most active storage as possible. They don't want to pay for backup ever. Yeah. So the whole data lifecycle is awesome, but who's going to pay for it? It comes back to what Tobin was saying. You've got to prioritize it from the beginning, how you're going to do this, who's going to do it, where it's going to go, and are you going to invest the resources? And if you're at a large facility, am I going to put a new funky sensor to analyze the data, or am I going to pay for the data lifecycle? What's the priority of that
Right.
process?
Yeah,
And-
I mean,
Go ahead.
I mean, that's a very, this discussion comes up every time in the CARC meetings, in many other meetings. It's mainly a sustainability question, right? And how does the funding flow for data management? That you do, like most of the times, indirect charging through the university is the way it's kind of done, not ideal, right?
You can convince your university to do that?
I mean, it's hard,
I
right?
mean, central IT grows by millions each year, whereas research computing has been flat for a decade.
Yeah, I know there are certain places who experiment with the condos of condos idea, where you provide some investment from your end, from the researcher, and then you get to leverage across the university system, right? So it's not exactly pay for play, but something similar to that. I know Clemson, I think, does condo of condos. I think Purdue has a similar model, but I'm not totally exactly familiar with that. So the different charging mechanisms are complex, as you said, right? And the other aspect, there's a question here from one of the participants, but I don't know whether he or she has joined in or not, right? So like, what are the best practices for getting researchers to curate the data, in particular taking it off working storage attached to HPC, right? So again, this managed backups is hard to pay for, right? Like, researchers are generating data, right? The storage is not unlimited. At some point of time, the scratch space fills up, right? And then the sysadmin comes to the researcher and says, okay, you just need to get your data off this machine. Like, what does the researcher do? So, right, I mean, these are some of the concerns. I mean, do you buy your own cold storage from a cloud provider and move things in there? Then you are becoming your own sysadmin for your data sets, right? You do all the managed curation yourself, right? Is that a right way of doing it? I know there are some universities who are having these agreements with Google or other cloud providers for unlimited storage for staff and fast transport to maybe a drive, to maybe Dropbox. So I think there are some efforts there, but this is a problem that's bubbling up in the research community, and it's bubbling up really hard, where people are really pressed for storage. And I think what your question was, Tom, was the third one in this list: how to get researchers pay for the proper data management over the life cycle.
And I'd say you cannot. It's impossible unless the funding agencies mandate it. And the reason why the funding agencies haven't mandated it is because they can't pay for it. It's very expensive to curate data, to do the metadata, to do the full life cycle. I mean, I have a petabyte of data of research data for my lab, and I don't back it up because I can't pay double the price. I'd rather pay for a student or a postdoc to do the work. It's a question of priorities. It comes back to what Tobin said in the beginning, is that you've got to plan it from the beginning, and I'll add, prioritize it. Decide that this is really critically important.
Yeah. So is that the general consensus in the CARC meetings? That
CARC, we don't talk about data lifecycle so much. We're more about workforce development and capabilities model and stuff. But it's ubiquitous in my experience.
Yeah, I actually meant the CASC meetings, not the CARC meetings. In CASC, we tend to talk about these issues, right? So.
Well, I mean, the biggest discussion is at the AAU APLU meeting, which has happened every year for the last, I've been to 2 or 3 of them, I can't remember now, where we bring librarians and VPRs and research computing people together, and we talk about how we all want to do fair data and all this stuff. And then at the end of the meeting, it's like, oh yeah, we can't afford this. So let's go meet again next year and talk about it some more.
Okay, so you think it's basically a resource constraint at this point to do anything?
Yeah, I mean, and for the large facilities, it's a question they have to decide of how much they want to prioritize the data. Are they willing to throw stuff away, or do they really want to keep it forever? And that's a cost issue.
Yeah, and I think that's one thing that large facilities are actually thinking about, and when they're doing some of the updates and migration, they are thinking about like rethinking their design from supporting FAIR principles being a first-class citizen rather than it comes later as an afterthought, right? So I think it's getting importance. And which means getting more funding behind it, like getting more people working inside large facilities to actually work on the FAIR aspects. So yeah, I mean, it's not there yet, but people are thinking. Doug or Rebecca, do you have any inputs on that? Doug, from the Sage Gauge angle?
Yeah, I was just thinking about it, and the interesting thing about Exceed not having storage is, yeah, that's right. We are actually working with Indiana to try and get some storage there. But the thing that came up to me was we're looking at cloud or commercial storage for a lot of our processing and stuff. And is this going to put up a barrier to researchers? Because now it's going to cost, well, it would cost us money for them to take data out. Are we going to charge them? I doubt it. So going back to Lifecycle, maybe this is something where we'll end up in our Lifecycle taking from commercial and pushing out to research institutes to keep our cost up.
Right. And then once you do that, you have to always remember that if you're doing that in the cloud, it's not necessarily cheap to do that, right? I mean,
right.
You have to pay all the egress costs. And again, it comes back to who is going to pay for what, right? Our researchers are used to getting all these services, quote unquote, free. There's an expectation that, it's going to be free forever, ever. And it's the same thing as Tom was mentioning, like data storage, right? Again, egress from cloud providers.
I think NASA is the example that did the experiment where they prepaid for a cloud solution and allowed researchers to download it, and immediately blew their budget within a few weeks because of that.
Yeah, I mean, that's a downside of moving everything to the cloud without a plan for your data egress, right? You either have to have negotiated cloud connects or express routes to your facilities and then serve the data from there. You might have to have a kind of backup or replica from where you serve it.
Right, it comes back to the pre-planning, and AWS, as one example, I know they do host some open data for like weather. Yes. And other stuff that's free, and they don't do egress charges. They do it as a service to the community. But if we started giving them 100 petabytes, they would not be so happy about that.
Absolutely. And yeah, I mean, one solution, they would say, okay, why don't you compute right there? I mean, but then that's not always possible. That you really want to use the entire ecosystem for computing, right? So and that's where the planning and change management actually come in. You really need to plan your CI deployment and also put the money in the right buckets. For example, as Tom mentioned, right? If you hadn't thought about the data egress costs, your budget is just gone right there. You thought you were you have a lot of advantage, but then you didn't think about that cost. So yeah, I mean, it's always a complex problem of multidimensional optimization problem, right? You have where, where where the cloud costs definitely start playing an important role in there. Yeah. So is Chris Ramses in here? Rajiv, can you check? He's from the.
There's no one named by Chris on the participants so far.
I think the fourth question is from Chris Ramses, who is from the Research Vessels team. He wanted to get a review of the RCR feeder life cycle, but I'll reach out to him later. Yeah, so we're about 15 minutes away from the end of this session. I would like you guys to, if you have any more questions, this is the time to ask them, and I would encourage you to attend the rest of the workshop. Encourage you to go to the CICOE pilot website to get more resources and more pointers and documents and links to things related to data lifecycle. We did have a paper at PERC on this, which has a lot more details, a lot more examples for data lifecycle, but mostly from the large facilities viewpoint. So I would encourage you to read that paper. Maybe I should have provided the citation here. Let me try to find it. I'll paste the citation on the chat. And if there are no more questions, I'd encourage you to attend the welcome and introduction talk at 1 p.m. for the workshop. And I'll be here in the next 15 minutes if anybody wants to ask any more follow-up questions. But I think we've covered some important aspects for the data life cycle, some things that are important concerns for the research community in general, not just for large facilities. And we understood some more nuances in the data life cycle. You understood some of the cost considerations and sustainability considerations for both for data storage aspects. And I would like to leave it here unless somebody else has other questions. All right. Hearing nothing, thank you for joining us for this office hour, and we'll see you in about 1 hour 15 minutes. Thank you very much.
Okay, so I'd like to thank everyone for their participation and attending, and thank you, Anirban, for leading the talks. Just wanted to remind you, everyone, that we make the recordings and the slides available and have them sent over via email. And if you would like to continue the discussions or have questions, we have a Slack channel or the Slack community channel, or a bunch of hallway chat channels where you can continue the conversation ahead. Thanks again. And please feel free to attend the next sessions or the other sessions. And if you want to know the links for the other sessions, I can send out the links on the chat here.
All right.
Thank you.
And I'll be here just in case someone pops in the last 5 or 10 minutes. Rajiv, if you can be here, that would be great to let people know.
Yeah, I'll be here till 9:15 at least.
All right. Thank you very much. Thanks. So I see someone joined in, Steve Barnett.
Yep.
Hi, sorry, I think we kind of wrapped up our session, but I'm happy to talk to you if you have any questions, and I can talk some more if need be. I do have what we call as a data life cycle for scientific facilities diagram here. And if you have any specific questions, please let me know, and we can take it from there.
I mean, I think that looks pretty good. I just got out of some other stuff, so I figured I'd swing in and see what people were talking about, how things were going. So
Sure, sure. I
no
think that,
worries.
yeah, some of the questions I think we have we partially discussed are whether the data life cycle captures the different stages that that your facility goes through. And I think you are familiar with this work, so I would not bore you with any more details. But
Never boring.
yeah, I mean, it's, I think more and more supporting FAIR principles, migrating to different other platforms, experimenting with cloud technologies, see if that works or not. These are some of the new issues that we have been hearing more lately. But and I know IceCube did an experiment with using the cloud platforms, right? So we did read that paper, and I think there was a presentation in either it was I don't know, it's a CAST meeting, or where we basically presented the different configurations of the multi-cloud providers. And but at the end of the presentation, I pretty much asked whether you're going to migrate to clouds for IceCube processing, and the answer was pretty much no. It's because of the cloud, because of the cost concerns, right? Even if even without the data egress charges, just the computing, I think the back of the envelope calculation doesn't make cloud attractive for IceCube, but it might be attractive for some other facilities where it depends on the amount of processing. And like, for example, in IceCube, the data egress might not be as costly as the compute cost, but for many other facilities which primarily serve the data to the community of users, distributing that data itself will be hard. I mean, because people are used to getting data for free, right?
Yes. Yep.
Whenever suddenly when they realize that to get data out of the cloud, it costs them money for every byte they transfer out, right? That's a very different model and mindset that people have to start wrapping their heads around, right? So yeah, there are definitely other solutions to get around that problem, but you really need to plan for that. Right? You could have like a on-prem backup, and you could serve it from on-prem, and you could have different things, right? You could negotiate with the providers to have like a Cloud Connect or Express Route kind of thing, and then you could get that cost down. But as soon as you let it loose, it becomes hard, right? And supposedly there was an experiment done at NASA. One of the officer participants mentioned that they tried experimenting with this model, and they just blew their budget within the first few days. So yeah, so it's any new toy, they have their pros and cons, right? So it's
Well,
sometimes
I think one of the things that will in the cloud platforms, and I'm seeing this across multiple areas of dealing with clouds and software as a service sort of thing, is keeping the cloud providers or the service providers honest in some ways. And so, looking and saying, okay, if I upload all of my data, and we decide we're going to use Amazon, well, the key calculation they need to do is, how much will it cost for them to, leave, and, set the price at $1 below that, right?
Yeah. So
and so the ability to sit down and say, look, we're going to use the commodity aspect of providing, or that the cloud providers offer and as soon as they try to raise the price, we simply shift to, you know, a different provider. You know, that mobility, I think, will be key, and that's a different set of systems in many ways.
Right, and whenever you have these types of concerns, we're trying to advise a lot of the facilities that you try to have a leverage on your side, saying that maybe you can keep a copy of data to yourself, right?
Mhm. Yep.
And then you have a lot more leverage when moving from one cloud to the other, right? And then you are not paying the egress charges to move the data from, say, Amazon to Azure, right?
Yep.
You'd say, okay, I have a backup here. I don't care about the data anymore. I'm just going to use Azure, and I'm just going to populate it because ingress is free, right? So
Yep.
I'm going to populate it from my on-prem, right? So then it becomes, again, a lot more complicated to manage and maintain this hybrid scenarios. So
Yep.
there's a cost for everything, right?
Yep.
And but somewhere it's a multidimensional optimization problem, as I always say, right? I mean,
Absolutely.
there's cost, there's performance, there is operational constraints, there are it's a space that needs to be really planned out and thought through, rather than just going with a solution and hoping that it's going to work, right, within the constraints. So yeah,
it adds another whole set of complexities to, you know, data management.
yeah.
I mean, we replicate into the clouds and we do things, you know, okay, results come out, you know, how do we know what's where? You know, if I want to process a chunk of data, you know, where should I be processing it right now? Where does it exist? You know, do I have to get it, or, you know, and then, you know, when I have results, how do I make sure they get put someplace permanent, not just in the cloud buckets that I delete because it cost too much this week?
Yeah. What is IceCube's take on this supporting FAIR principles? This is coming up very often nowadays whenever I talk to facilities. So what's your angle to it?
I mean, I think we generally support it. You know, it's you know, it offers some definite challenges, you know, in what we do, but you know, it's you know, it's definitely, you know, all of those things are all good, you know, I guess from our perspective. You know, there's some parts of it, you know, that obviously it's like, okay, you know, looking and deciding when, you know, when data becomes public and exposed, you know, versus internal and privately analyzed and things like that, you know, is really a, you know, a very kind of hot topic for us, you know, because our model has been, and you know, we have the data, we do our own internal processing. As we publish results, we publish the data to go with it.
Right.
But it seems like there are pressures that come in some ways kind of from the astronomy community, where they just, you know, they take the data and then it's just out there, and, you know, individual researchers or citizen scientists can pour through it as well. You know, and what would that do, you know, in terms of, you know, how our collaboration operates?
Sure. Yeah, I mean, in a way, it's relatively less relevant for IceCube than for a facility, say like Sage, Gauge, or OI, or Neon, which are primarily distributing their data sets, right? Their collection, and those facilities rarely do processing for the users inside their facility, right? So whatever they do is mostly the standard processing, like your level 2 processing maybe, right? So standard processing, standard products, and then they're distributing it. So for those facilities, supporting FAIR principles is a lot more structured exercise than say for IceCube, where it's pretty much is mostly a collaborative model rather than it's a fan out model, right? So So those facilities are mostly you have the data and you're just fanning out to your research community, right? So
Yep.
IceCube does that partially, but then there's a large portion of IceCube which is this collaborative processing across this distributed resources, right? And
yep.
It's kind of difficult to actually answer what fair means in this context. Does fair mean only for the last bits of data that the community generates? Does fair encompass every data element that IceCube produces, that IceCube collaboration produces, right? So
Yep.
it's a different take, and it's hard to answer that question from your perspective, if I understand correctly. So.
Well, it has some, potentially profound impacts, largely on the budget process, right? So we have a portion of our budget comes from the National Science Foundation, but there's another portion of the budget that comes from the collaborating members in the institution or in the collaboration. Each of those institutions, sends money. Now, if we said, okay, let's reconceive of ourselves as as one of the others, where we simply get it to level 2 and then we make it available, we release it. At that point, then we get some very different, a very different model, and we say, okay, wait a minute, do we then have to go back to NSF and say, hey, this portion of the the budget which was coming from contributions in these other areas is now gone. And that those are the sorts of issues we run into if we go there. But you can look and say, okay, at some point, there is, we do have, we have to release the data. And when you look at the principles that are laid out in that FAIR framework, at least if we're internally following them, so that there's no distinction in dealing with the data between what we deal with internally and what's eventually released, that will smooth out that process. So,
yeah.
Sorry to interject. Just wanted to let you know we are at the end of the session. Feel free to continue talking, but I just wanted to let you know. So if you had plans on attending any other sessions, you don't miss that.
Sure. All right.
thank you.
Thank you, Rajiv. I think unless Steve, you have more questions, I'll grab some. And then
No, thank you much. I appreciate you.
Nice seeing you, even in these times.
Yes.
Other times we'd have definitely met in some meeting or some conference, but
Yeah. Yep.
yeah. All right.
Yeah, I've just been happy that we're that it's happening in these times, because go back even 10 years and this sort of interaction would simply not have been possible. So it's not great, but
all right. I think
thank you.
That concludes the session. If somebody pops in, you can ask if they have a specific question. I'll be happy to answer that, but the session has ended.